Unveil the enigma of the universe. Embark on a breathtaking expedition to the very edge of scientific knowledge as we plunge headfirst into the mind-bending depths of black holes. Brace yourself for a mind-altering odyssey, where reality warps, time distorts, and the laws of physics cease to exist. Join us on an extraordinary voyage as we unravel the secrets of these cosmic abysses and venture into the heart of darkness. Black holes are a scientific mystery. There is so much still to discover. The first image of a black hole was captured in April 2019. Much of what we know about black holes is a theory or based on observations of objects near or behind a black hole. How are black holes formed? A black hole comes from the death of a large star, at least 10 times bigger than our Sun, exploding at the end of its life in a supernova. The Sun, being too small, won't ever become a black hole. It will expand, contract, and cool off in its death process. Constant fusion. The constant fusion of hydrogen to helium creates the energy and radiation from a star. A star is in a stable state for most of its life as the energy pushing out from the star balances with the gravitational force pulling in. At the end of a star's life, stars like our Sun will continue fusing elements like helium to carbon and carbon to neon, but not much further. Large stars will continue fusing elements until the star reaches iron. Iron is a very stable element, and gravity alone cannot compress it further. Iron builds up in the core, and the internal pressure of energy radiating outwards becomes out of balance with the pressure of gravity pulling inwards. The outer layers of the star are no longer supported by the radiation pressure of nuclear fusion, and the star's gravity pulls the outer layers into the core. When the incompressible core connects with the outer layers, a shockwave is sent through the densely packed star, which results in the fusion of other elements on the periodic table after iron. The black part of the black hole is the event horizon. If an object breaches the event horizon and approaches the singularity, it will become spaghettified, stretched and pulled apart by the black hole's gravitational forces. Scientists think that in the middle of the black hole is a singularity. It's at this point in the black hole discussion that classical physics principles can no longer be applied. It stops making sense in this context, and quantum mechanics takes over. The theory is that the singularity is an infinitely small point where gravity and density are also infinite. The black hole is packed with all the heavy elements from the star, but in a much smaller space. Imagine the mass of a star 10 times the size of our Sun compressed into something the size of a city. Creating the first photograph of a black hole. Black holes are fascinating because there is so much we don't know. It's an area ripe for investigation, and NASA is doing just that. There is a NASA campaign underway that aims to understand black holes further. From 5 to 14 April, astronomers used a network of radio telescopes to look at the gigantic Sagittarius A** black hole located at the center of our galaxy. These telescopes were all pointing towards Sagittarius A* and worked together to create the first photo of a black hole. The data from the radio telescopes will be converted into an image. Stellar black holes, supermassive black holes, and intermediate mass black holes are the most common types of black holes, and each of them has been studied extensively by astronomers. Through the use of astronomical instruments, scientists have been able to uncover some of the secrets of black holes and make discoveries. Types of black holes. There are many different types of black holes, and they can be grouped into several different categories according to their size and origin. There are several different types of black holes, each with different attributes and formation processes. Stellar black holes. Stellar black holes are formed when an extremely large star collapses in on itself and ends its life with a supernova. When a star becomes a black hole, it collapses so rapidly that it forms a singularity, a single point of infinite density. Stellar black holes come in different sizes, with bigger ones being formed when larger stars die. The most massive known stellar black hole is Cygnus X1, which is believed to be around 30 times more massive than the Sun. Stellar black holes are formed when a very large star collapses in on itself and ends its life with a supernova. In most cases, stellar black holes are invisible because they don't emit any light. If the black hole happens to be rotating, it can emit matter along its equator, creating an accretion disk that shines very brightly. Stellar black holes emit X-rays and can be observed with powerful telescopes. Supermassive black holes. Supermassive black holes are formed when many large stars collapse and merge over billions of years. When stars die, they collapse in on themselves and produce a supermassive black hole. Over billions of years, the black hole grows larger by sucking in gas and dust from its surroundings, increasing its mass. There are many examples of supermassive black holes that are found at the center of galaxies. The supermassive black hole at the center of our galaxy is named Sagittarius A*. A supermassive black hole is formed when many large stars collapse and merge over billions of years. That might sound like a very long process, but keep in mind that stars are constantly forming out of interstellar gas and collapsing into new stars. While the black hole is growing larger and larger, stars are being born and dying all the time. Stellar black holes are formed when very large stars collapse in on themselves and end their lives with a supernova. The largest supermassive black holes are believed to have formed when several smaller stars combined. Intermediate mass black holes. Intermediate mass black holes form when two normal mass black holes collide with each other and merge. These black holes are smaller than stellar black holes, but larger than supermassive black holes. At the Milky Way galactic center, scientists have discovered evidence of a dense cloud of gas that they believe is the result of a collision between two intermediate mass black holes. The collision between the two black holes created a highly dense blob that is emitting X-rays. Astronomers believe that it will eventually collapse into an even denser blob that will eventually form a new black hole. The intermediate mass black holes that formed at the center of the Milky Way are believed to be the result of many smaller black holes colliding together. The enigmatic allure of black holes remains a captivating cosmic riddle that beckons humanity's relentless pursuit of knowledge. So, let us embark on this extraordinary journey together, fueled by curiosity and boundless imagination, forever captivated by the wonders that lie within the mysteries of black holes. If you found our video informative, kindly subscribe to our channel so you won't miss out on our videos.